Okay, this is notes on polar coordinates or polar systems. And if you don't have out your calculator, go ahead and get it out. I'm going to show you how to graph these. So that's what I'm going to do first. So here is your first equation that we're going to go ahead and graph. So let's go to our calculator and graph that first. Okay, so in your calculator, let's go to mode first. And on your mode, if you notice, I have mine in radians. And you're going to go ahead and change the function to polar. The POL is your polar. And I'm going to go ahead and change this down here to simultaneous. And what's going to happen is it's basically going to take whatever you put into your y equals, and it's going to graph it at the same time. Okay? So now let's go to y equals. And I went ahead and put my equations in. So if you would type in your first equation, so it's 1 minus 2 cosine theta, and it's your x button, and then r equals 1. And now what I want to happen is I want you to scroll all the way over here. And if you press enter, what y'all are used to doing is pressing enter, and it makes it a bold. And I'm going to press enter one more time, and it looks like a little football. I know you've done this in algebra before. And it leaves a line after it. Okay? I'm going to go ahead and do that on both of these equations. Now on zoom, I'm going to go ahead and do a zoom 4 so that I have a decimal. So everything is on plain Jane decimals in your window here. So let's go ahead and graph that and see what it looks like. So it kind of leads you, you've got your little footballs here to see what happens when you're graphing. And if you notice, they're hitting right there. And if you didn't notice, you can regraph. I wanted to see where they met. And I noticed that they met right here. And when they first met, those footballs intersected here as well. Now it looks like your two equations also meet here and right here at the origin, or since we're in polar, this is the pole right here. Okay, so when they graphed, they met up here and down here. They did not meet at this point, and they did not meet at the pole. Okay, so they met at these two sections right here. All right, so I'm going to go back. And then I'm just going to do a quick little sketch of that so that we have it in front of us. Not going to be great. Okay. But it would be nice if we have that sketched on our paper. So it looked like, since I did decimals, that this went up to about 1. So I'm going to do a circle of about 1. Hoping I can do a circle on here. And then I had this circle here. Okay, I'm going to go back to my graph. So this is at 1, 2, and then another circle at 3. Okay, so this is 1, this is about 2, and this is about 3. Just to get an idea. Woo, that's a crazy circle. Okay, and again, it looked like there was an intersection right here at this point and right here at this point. Okay, now this was up 1, this was down 1, so of course I know my radius is at 1. Okay. Now, if you go up or you go down, you should know those coordinates. So if I go straight up and down, that coordinate is pi over 2. And I know this is pi. And if I go down here, this is 3 pi over 2. Now, on your calculator, usually we would find our intersection by pressing second and then trace. And if you notice, there is not a calculate or a trace button on this, or an intersection. So that's going to be kind of difficult. What you can do is you can just press the trace button, and you can just arrow around to see, and it just kind of follows you around. Now, right here is where I have my point. This is at 0, and this is 1, and this is my point right here. This is 1.57. Now that's pi over 2. Now you may not know that, but since we know straight up and down is pi over 2 and straight down is the 3 pi over 2, that makes it really easy. Now if it was something other than that, I'm not sure I would know that, but I just wanted to let you know that there is no intersection button when you're in polar coordinates. Okay, so this is the graphing mode. All right, so let's go ahead and do this algebraically and see what happens when we do that. So to solve algebraically, so to do this algebraically, of course, what we need to do is go ahead and set this equal to each other. So I'm going to say 1 is equal to 1 minus 2 cosine of theta. And I would subtract the 1, so 0 equals the negative 2 cosine theta. Divide by that, so I still have a 0. Whoops. Okay, at this point, I'm going to go ahead and move my cosine, so I have an arc cosine. So I've got 0 equals an arc, theta equals an arc cosine of 0. At this point, what you're going to do is find your general solutions. Now, this shouldn't be hard. I hope you can remember this from at this point, or I hope you can remember this. So I'm going to write down general solutions. Now remember, when you were finding your general solutions, you're trying to see where cosine is 0. At this point, you might need to write down your OIO chart. And I will go ahead and do that really quick, or you might want to go ahead and do that really quick. So there's sine, cosine, and tangent. Remember, OIO starts with a 0, the 90, 180, and 270. Okay, so cosine is 0. Where is cosine 0? At 90 degrees. It's also 0 at 270 degrees. So I'm thinking up here at 90 degrees and down here at 270. Now this is going to be in radians, so I'm going to write my general solutions. So I'm going to say theta is equal to pi over 2. That's my 90 degrees. And remember, when you write your general solutions, you say plus 2 pi n. My other general solution down here was 270, so that's going to be 3 pi over 2, just like we said over here when we graphed it. So theta is equal to 3 pi over 2, and I always add my 360 in. So here are my general solutions, just like we found, or my intersections, just like we found on the graph. So I'm going to write this as an ordered pair. Remember, when you write this, you always write your radius first. Okay, so my radius, which was given in this one, so I'm going to move it back up. My radius was given, and it was radius of 1. So my solutions in this are going to be 1, and my angle is pi over 2. So this is going to be a solution. And then in my second one, my radius is still 1, and this is 3 pi over 2. Okay, so we found it graphically, and I just showed you how to find it algebraically. So again, these are my solutions. Okay, now, one other thing that we need to go ahead and find is called, or another solution is the pole. Is there a solution at my pole? Now, these did intersect right here at the pole. Okay, now we found graphically that these intersected at the pole, but we want to find algebraically if they did. So how you do this is you let r equal 0. Okay, should be just as easy as that. So in order to do that, I'm going to go back to my equations over here, my original equations, and I'm going to say 0 is equal to 1 minus 2 cosine cosine of theta, and I'm going to go ahead and solve this. So I would move the 1 over, or that would be subtracting the 1, so that would be a negative 1. That's going to be a negative 2 cosine of theta. Divide by that, that's going to give me a 1/2 equals a cosine of theta. If I keep going, this is going to give me an, let's see, theta equals an arc cosine of 1/2. Now, what happens here is I want to know, is there any way that you can find an arc cosine of 1/2? So if you were to draw your triangle, is there any angle like this, meaning cosine is adjacent over hypotenuse? And I know that this does exist. This is, what, a 60-degree angle? So I'm going to stop here. I'm not going to go any further. And in fact, I didn't even need to draw that triangle because this exists. Okay? Now, I also need to test out my second equation, which is r equals 1. And again, you set it equal to 0, so I'm going to say, instead of r equals 1, I'm going to say 0 equals 1. Now, 0 does not equal 1. Since 0 does not equal 1, the pole is not a solution. Remember, these 3 dots is therefore, the pole is not a solution. Not a solution. Now, you should have known that by the graph, because I talked about how when you were graphing, the 2 lines hit each other at this point and this point, but not at your pole or your origin, and not here. Okay, so these are my 2 solutions, and that's it. Okay, let's look at the second example. And your second example is r equals sine of theta and r equals 1 minus sine theta. Okay, if you notice on this one, I do not give you your radius on this one. Okay, so we're actually going to have to solve for that one. So the first thing I want to do, go ahead and set these equal to each other. So sine theta is equal to 1 minus sine theta. And solve. Let's get the signs together. So I'm going to add this sign to both sides. And that's going to give me 2 sine theta is equal to 1. And let's see, divide by 2. Sine theta equals 1/2. And then I'm going to go ahead and do arc sine. So theta is equal to arc sine of 1/2. Okay, for those of you who need to draw and figure this out, I'm going to see what angle gives me the arc sine of 1/2. So basically, think of all students take calculus. So this is going to give me opposite over hypotenuse. This is root 3. So this is a 30-degree angle right here. And so a 30-degree angle is going to give me pi over 6. So my general solutions, let's see, I'm going to write them out here. Okay, so my general solutions, my first one is going to be pi over 6, because this is my first triangle here. So I'm going to say theta is equal to pi over 6, and remember, you always add 2 pi in. Okay, where else are we going to have an angle that's going to give you a positive sign? So all students take calculus. So it looks like it's going to be over here in this. So sine is positive over here as well. So 30 degrees, again, this is going to be a 30 degree, okay? So if this is pi over 6, what is the angle going to be over here if this is going to be my angle over here? So that should be 5 pi over 6. So 5 pi over 6 plus 2 pi n. All right, so here are my angles that I'm working with. Now remember, I didn't give you what the radius is. So we're going to have to solve for the radius. Okay, so what are we going to do to solve for the radius? Whoops. So what is your radius? So in order to find out what my radius is, let's just pick one of your equations. I'm going to pick the most simple one. It looks like the top one. So the top equation is r equals sine of theta. And let's plug both of our angles in that we have found. Okay, so this first one is pi over 6. So r equals sine of pi over 6. And I just need to find out what r is going to equal, basically your radius when I have pi over 6. So again, I can look over here at my angles or my triangle that I've already drawn, and I can do sine, which is opposite over hypotenuse, and that's going to be 1/2. So r is 1/2. And if I do my same equation, because it's more simple, use my second angle here, or my degrees, which is, let's see, sine of 5 pi over 6. Again, I can use my drawing because I've already drawn it. Again, I'm going to have the same thing here. This is 2, 1. This is going to be a negative root 3, if that matters. Sine is going to be opposite over hypotenuse again. So this is 1/2. Okay, so we write radius and then your degree. So I'm going to have 1/2 and pi over 6. And that's going to be one solution. And I have 1/2 again and 5 pi over 6. And that is a second solution. All right, so now we need to check for the pole. Is the pole a solution? Now remember, the pole is your origin, so is the pole a solution? And remember how you do that is you say r is equal to 0. Okay, so I'm going to take my original equations, which are r is equal to sine theta, which is the one I just got through working with, and I'm going to put r is equal to 0. So 0 is equal to sine theta, and I'm going to solve for this. So basically this is arc sine, oh, I got something crazy there. Oop, that didn't go away. So let's see, theta is equal to arc sine of 0. If you would like to, you can look at your OIO chart again. Basically, I want to know, is there an angle that will give you 0 for sine? Okay, and it looks like there's 2 of them. Okay, so you can move on and say that since this does work, I can move on, and that works. Okay, pick your second equation, which is r equals 1 minus sine theta. Let me move it over a little bit here. R equals 1 minus sine theta. Plug in a 0 for your r. And solve. Let's see, if I subtract, then I get a -1. Divide, that's going to be a +1, and then I'm going to go ahead and set up my arc sine. So arc sine, or theta equals arc sine of a positive 1. Okay, I'm going to go back and see if that's on my chart. And it looks like it's there again. So that does exist. So that means since it works for both of them and these angles do exist, my pole or my origin is a solution. So I've got 3 solutions. If you were to graph these two systems, they're going to intersect simultaneously at 3 different points or 3 different places. Okay, one thing that you also need to think about is that these 2 points right here, as you can see on my graph, if you were to graph 1/2 and pi over 6, that's probably over here somewhere, and then 1/2 5 pi over 6, you can see that they're 2 different points. Okay, so they intersect here, here, and at the origin at some point. Okay, let's move on. Okay, so my third one, I've got r is equal to 2 root 3 cosine theta, and r is equal to 2 sine theta. Still don't know what my radius is, and I'm changing it up where I've got a sine and a cosine. Okay, go ahead and set them equal to each other and find out where they intersect. So 2 root 3 cosine theta is equal to 2 sine theta. I would probably divide by, let's divide by the 2 first, get rid of them. So that gives me a root 3 cosine theta, and that gives me a sine theta. Okay, how about let's divide by cosine on both sides. That gives me a root 3. If I divide by cosine here, that leaves me with a tangent. Kind of thinking ahead here. Now I can do arctan of this. So theta is equal to arctan of root 3. I know that was kind of strange, but I was kind of trying to think ahead of that one. Okay, if you were to look at this, I'll draw a graph for you. So all students take calculus. Tangent is opposite over adjacent, so this is root 3 over 1, and this is 2. So it looks like this is, what, a 60-degree angle? So my general solutions are theta is equal to, let's see, 60 is going to be what, pi over 3? Now remember, tangent is not adding 360, it's adding just 180, so I'm going to say plus pi n. Now where else is tangent positive? All students, it's positive down here as well. So you would be drawing a triangle here at 60 degrees, okay? This would be 1, I'm sorry, this is 2. This would be negative 1, and this is negative root 3. Again, you don't have to worry about your negatives, because if you think of all students take, really, this is still going to be a positive root 3. Okay, so this is going to be 4 pi over 3. Okay, so this is 4 pi over 3 plus pi n. So here are my 2 angles that I'm working with. So I'm going to find my r, just like I did on the other one. So what is r? Okay, in order to find r, pick your easiest equation. Looks like it's going to be the second one. So r is equal to 2 sine. Go ahead and plug in your angles that you found. So that's going to be pi over 3. And basically what you're doing is you're going to do 2 times that sine of pi over 3. And since I've already drawn these, it's going to be super easy. So sine of pi over 3 is going to be opposite over adjacent. So square root 3 over 2. So times square root 3 over 2. And so my r in this case is just root 3. So my ordered pair is going to be root 3, and my angle is pi over 3. There's my solution. For my second one, this is going to be 2 times the sine of my next angle, which is 4 pi over 3. It's kind of messy. Hope y'all can read that. Okay, so 2 times sine of 4 pi over 3. In this one, let's see, sine opposite over hypotenuse. Yeah, opposite over hypotenuse. Again, that was a negative root 3 over 2. Again, messy. So this is negative root 3 over 2. So my radius in this case is negative root 3. My solution in this one is going to be negative root 3. And this is 4 pi over 3. Okay, let's go ahead and find our pole. I hope your pole is getting a whole lot easier. Your pole is where r equals 0. Where r equals 0, you're going to take your equations and just substitute that in. So my equation is r equals 2 root 3 cosine of theta, and I'm going to plug in a 0 and solve, and you're trying to see if there an angle exists with that. Okay, and this one, let's see, what are we going to do? How about we divide by the 2 pi over the 2 root 3, so that's still going to be 0. And then how about theta is equal to arc cosine of 0? And we've done this 100 times. Does this angle exist? Can you find an angle that gives you an arc cosine of 0? And this is a yes. Okay, let's try our second one. That is r equals 2 sine of theta. Replace the r with a 0 and solve. Divide, that gives you a 0. And then it looks like you've got an arc cosine. A theta equals an arc sine, of 0. And does this exist? Can you find an angle that gives you a 0 for sine? And this exists as well. That means that your 0, 0, your pole is an intersection of these two equations. So this is the solution, this one in, and so is your pole, which is your origin. Okay, so that's a solution. Now, on the previous problem, I talked about these 2 points, and I wanted to show you on this one. If you were to graph root 3 and pi over 3, so you've got, it's probably about right here. If you were to graph 4 pi over 3, which is over here, and then do the negative root 3, you end up in the same place. So realistically, these two are the same thing. So do you need this second answer? No, because it's exactly the same as the first. Not a big deal if you put it, but it is exactly the same answer. Okay, hope this helped. We'll talk more Monday if you need some more help.